All right, we're continuing to talk about change of amplitude. And now what we have here is we have f of x is equal to 2 times sine of x. Not simply sine of x, but 2 times sine of x. And we want to graph one standard interval of this function. So just one time through the water, we're going to do this. We're going to go x, f of x, just one time through. Let's actually use our little grid here and see what happens. Once we see what's going on, then we won't need to use this grid anymore. We'll be able to look at this equation and be able to draw the graph immediately from it. But the first time through the water, let's go ahead and play this. If I choose x to be 0, what is 2 times sine of x? Well, I know what sine of 0 is, because I know what the sine curve looks like. I know sine of 0 is 0. This is if the 2 were not present, that's the picture I'm talking about. And so sine of 0 is 0, but I am going to multiply by 2. So this would be 2 times sine of 0, which is 2 times 0, which is 0. So we have the point 0, 0. And so my point on my graph here, I have 1, I have -1, I have pi, I have 2 pi, there's pi over 2, there's 3 pi over 2. So I have my little picture here, 0, 0. There we go. We are moving now. Now, what else do I choose for my x? Now, remember, we don't choose 1s, 2s, and 3s. We choose multiples of pi and pi over 2. So if I put pi over 2 here, I want 2 times sine of pi over 2. Well, what is sine of pi over 2? Sine of pi over 2, right, we know what sine of pi over 2 is. In the ordinary sine curve, sine of pi over 2, in the ordinary sine curve, sine of pi over 2 is 1. So sine of pi over 2 is 1. This is 2 times 1, which is 2. So I get input pi over 2, output 2. So at pi over 2, the function value is not 1. Pi over 2, the function value is 2. All right, what happens at pi? Well, what is sine of pi? Sine of pi is 0. How do I know sine of pi is 0? One way, just throw it in the calculator. Make sure you're in radian mode. Sine of pi is 0. Another way to think of it is this. Here's the unit circle. This is 1, 0, 0, -1, 0, 1 rather. -1, 0, and then 0, -1. Sine is the y coordinates, 0, 1, 0, -1, 0, 1, 0, -1. So sine of pi, there's my pi, sine of pi is 0. Sine of pi is 0. I also know sine of pi is 0 because I know the basic picture. There's pi. The basic picture, not this new one, but the basic picture is 0 at pi. And so sine of pi is 0. 2 times 0 is 0. So what I have is pi, comma, 0. So on my graph, pi, comma, 0. At 3 pi over 2, I know the basic shape sine curve goes to -1. So if the 2 were not present, sine of 3 pi over 2 would be -1, but the 2 is present. 2 times -1 is -2, which is, here's -1, here's -2. And then at 2 pi, right, at 2 pi, that's where the sine curve comes back up to a node. If the 2 were not present, all we would have is sine of 2 pi. But 2 pi is 0. Sine of 2 pi is 0. And 2 times 0 is 0. So we have 2 pi, comma 0. And so what do we gain from all that? What do we glean from it? This multiplying by 2 says we have the same values, but anything that's above the axis is doubled. Anything that's below the axis is doubled, but points on the axis are not changed. So whereas if the 2 were not present, if this 2 were not present, if all we had were sine of x, the graph would look like this. If the 2 were not present, it would just be the ordinary sine curve. But instead of 1, it goes up to 2. And so this stretches up higher. The actual graph of 2 times sine of x stretches up to 2. And instead of bottoming out at -1, it would bottom out at -2. So it stretches downward to -2, and then it would continue in both directions. And so what has changed here? Well, the standard period is still 0 to 2 pi. The standard period has not changed. What has changed is the peak line and the trough line. What has changed is the amplitude. What has changed is the amplitude, because it is not hard to see. If 10 minutes ago, instead of choosing 2, if I had chosen this to be 4, the multiplier would have been 4. This still would have been 0. This would have been 4. This still would have been 0. This would have been -4. This still would have been 0. And so if the multiplier is 4, this would have gone all the way up to +4, all the way down to -4. If this multiplier had been 10, we would have gone all the way up to +10, but then come back. It still has to go through the nodes, because these nodes don't change, because 0 times anything is going to be 0. And so if the multiplier had been 10, it would have a very high amplitude going way up to 10 and way down to -10. What if the multiplier had been 1/2? What if this multiplier had been 1/2 instead of 2? Instead of going up to 1, or instead of going up to 2, or instead of going up to 4, if the multiplier had only been 1/2, it would have only gone up to 1/2, and then down to a -1/2. And so what pattern are we seeing? That if we have a multiplier outside this function. Now, there's another way to think of this. There's another kind of function. What if we had sine of 2x? That is not what I'm talking about. I'm not talking about multiplying inside the function. I'm talking about multiplying outside the function. This value corresponds to the amplitude. That value corresponds to the amplitude. It always corresponds to the amplitude. It's the same for sine as it is for cosine. This value corresponds to the amplitude. Everything else stays the same, except the amplitude is changed. In this case, the amplitude is 2 instead of the amplitude as being 1. So the parts that are above the axis stretch further above. The parts that are below the axis stretch further below. If this is a fraction between 0 and 1, then the parts above the axis get squashed. Part below the axis gets squashed up. And so this can be thought of as a stretch vertically or a compression vertically. Typically, we simply say a change of amplitude. And anyone who knows what you're talking about knows what it means to change the amplitude. And so once we know that, once we know this multiplier means a change of amplitude, this is the advantage. Here it is. You no longer need this stuff. You no longer need any of this to sketch the graph of this readily, lickety-split. Because let's now consider, new problem. We now consider f of x equals, let's do sine, but let's do 5 sine of x, 5 times sine of x. What is this? First off, what I'm going to ask of you, when I have you draw these graphs, and I will have you draw these graphs, I will have you draw them by hand. A computer-generated graph is not enough. There are times when you need to be able to sketch the graph without reference to a machine. So it is wonderful to be able to know how to make a machine do this. That's a grand skill to have. That's not what I'm after. You need to be able to sketch this out freehand, which means you need to practice it and have it become part of your skill set. When you do that, this is what I'm going to require. When it says using the methods discussed in the videos, using the methods discussed in the lessons, this is what I'm talking about. If you do not show this work, you will not get credit out of me. You are free to take. There are thousands, I'm sure, thousands of people across the country who teach trigonometry much better than I. But this is the way it's going to work for us. First off, what is the amplitude? What is the amplitude? Make a little, you can abbreviate, that's fine. The amplitude is 5. So what's the basic shape? Not just what is it verbally. Draw a sketch. Draw a rough little sketch. Forget the 5. What is the basic shape of that? This is what I want to see. A rough little sketch of the sine curve. Just a rough, quick little sketch of the sine curve. Just like if we say, what does a quick little sketch of absolute value look like? That's a quick little sketch of absolute value. What's a quick little sketch of the parabola? That's a quick little sketch of the parabola. What's a quick little sketch of the sine curve? That's a quick little sketch of the sine curve. The amplitude is 5. I should be a little bit more explicit. The amplitude is the absolute value of that number. The amplitude is the absolute value. It's the absolute value of this number. If this is -5, the amplitude is not -5. If this is -2, the amplitude is not -2. If this is -5, the amplitude is the absolute value of -5, which is 5. Amplitude can never be negative. Amplitude can never be negative. Amplitude can never be negative. No matter what else happens, if you have a negative amplitude, it's wrong. And if you can't smell multiple choice coming there, you're not sniffing very hard at all. So what's the amplitude? The amplitude is absolute value of 5, which is 5. Basic shape. For that, so far, that's all we need. Now, pretty soon, we're going to be adding more and more to this. But for now, that's all the shape, all that we have. We have the basic shape, we have the amplitude. And so your graph then would do this. 1, 2, 3, 4, 5. Just 5. That is now the peak line. So every time you draw these by hand, every stinking time, amplitude, make the peak line. Amplitude, make the trough line. Every time. Now, if this is 1, 2, 3, 4, 5, look, this is about 3, so that's about pi. Make your scale about the same. Do you see what I did there? 1, 2, 3. That's 3. See, this distance is 3. If that's 3 on the y-axis, then this is about 3 on the x-axis. A little bit more than 3 is pi. So the way you make your scale close to being correct is just choose your 3 and copy that here. So 3, 3. If you have lined notebook paper, it's really easy because all you need to do is just take 3 lines and approximate 3 lines. But here we go. 1, 2, 3, 1, 2, 3, and a little bit more is pi. If that's 1 pi, this is 2 pi, this is pi over 2, this is 3 pi over 2, and then, so this is the standard interval. Do this. Make a little dotted box. Every time you do one of these, I am going to be looking for that rectangle. If you do not have that rectangle, you are not getting credit out of me. You will be thanking me for this later on in your calculus course when you need to have some graphs of these things. But for now, you need to have this rectangle. The top is the peak line, the bottom is the trough line, and the sides are the endpoints of the standard interval. Now, we need to make this shape. So we use this basic shape, needs to match into that picture. Start at the node, peak, node, trough, and then node. And I go ahead and put the dot's fine. We can put the dot there. If you want to make that open circle, that's wonderful. If you want to fill it out, that's fine. Node, peak, node, trough, node. Node, way up honkin' peak, node, way down honkin' peak, or trough, and node. And then once you have those four, we have 5 basic points here, just play connect the dots. And so we have this. If you show me this, then I will be very forgiving of the quality of your picture. If your picture is not wonderful, spectacular, professional grade quality you see here, if your picture is not quite as wonderful as it could be, I will be forgiving here if you show me this. If you do not show me this, then it doesn't really matter how good your picture is, you are not going to get credit out of me. So, f of x is equal to 5 sine of x. This is the first of our examples of changing of amplitude. So next video, we'll go through maybe without quite so much explanation. We'll go through several examples of change of amplitude with sine and of cosine, and we will go through several examples of that, so that becomes very familiar to you in your ability to graph the sine and cosine functions.